Hey developers, welcome back to the channel. Today, we're going to build a decentralized identity dApp on top of Rootstock blockchain. This is where Bitcoin security will meet a new Web3 identity infrastructure. So, your identity is basically the most valuable digital asset you own. Right now, it's like controlled by big tech giants like Google, Facebook, governments. They own your data. They can even sell your information to others and even ban you from the app without any explanation. Right? But what if you owned your self-identity? What if your credentials were verifiable on chain? What if you have the right to your intellectual property of your identity? That's what we are going to build today. A self-sovereign identity system powered by Rootstock Bitcoin security, storing data on IPFS and accessible through a beautiful React interface. Right. So now let's just check out our core features, which we are going to build today. DApp will include blockchain-based DIDs following W3C standards. We'll store identity documents on top of IPFS hashes on chain, and we'll have the issuing and verifying credentials features. And thereafter, we will have a simple secure architecture which will involve React, MetaMask, and Rootstock smart contracts. Okay, now as you can see in this architecture diagram, we'll have three layers. First of all, we have the user layer. You interact through our React dApp in the browser and use MetaMask to interact and sign transactions. Thereafter, we have the client layer, which is basically our React frontend, which handles UI and IPFS integration. It's all client-side, no server-side things, backend controlling your data, basically. Thereafter, we have our one of the main layer, which is our blockchain layer, which will be on the RSK testnet with Bitcoin security. We will host our identity registry.sol smart contract. It will basically store mapping addresses to IPFS hashes of our identity documents. Now here's the flow, what it looks like. First of all, user will create identity through our React app. Thereafter, MetaMask will sign the transaction, and smart contract will be writing the transaction to the blockchain. Anyone can read identity through the data, and all of our data will be verifiable, and all of transactions are transparent as of RSK testnet. This is beautifully simple but incredibly powerful. No complex backend, no centralized database, just blockchain truth and decentralized magic. So by the end of this tutorial, you'll get to know about writing identity registry contracts in Solidity, storing the IPFS hashes on-chain efficiently, and access control ownership processes. You'll have IPFS integration, which will basically upload files to IPFS from browser and retrieve content via IPFS gateways. And front end, we are going to use React with TypeScript for type safety and wagmi hooks for wallet integration, Veeam for smart contract interactions through Ethereum. We're going to use Remix in order to deploy our smart contract. It's basically an online IDE. And we have the Rootstock specifics, which are configuring MetaMask for RSK, deploying to Rootstock Testnet, and working with TRBDC. Okay, before we begin, these are some prerequisites you would have to install on your machine. You would need Node.js 18 or higher, MetaMask browser extension, and a code editor. Here, we'll be using Cursor here. Okay, and you should also have a little bit of knowledge of basic Solidity, JavaScript, TypeScript, and React basics and blockchain concepts. Don't worry, if you don't know, I'll explain them to you. Okay, so that's all we need in order to build this app. Now let's just go ahead and code it right away. Okay guys, so here we are. If you don't have the Rootstock testnet, you can just go to the chain list and Rootstock testnet, and here you get all of the details of RPC and its testnet, and you can just connect your wallet and add the testnet to your wallet. It's too simple. And if you don't have the Rootstock tokens on the testnet, just open up my wallet. So I'll just head over to the Rootstock testnet and just copy my address and press I'm not a robot and get the RBTCs. It takes 30 seconds. So till then, we can head over to remix.ethereum.org in order to build our smart contract. This is basically an online IDE which is used to develop smart contracts. We'll create a new workspace. We'll create a blank workspace, and in it, we'll name it as DID. And here, we will make a smart contract named as identity. .sol is basically the Solidity extension of the file. So this interface is basically used to develop the smart contract. We can write our smart contract here and deploy it to the deploy tab. Okay, so let's just start developing our smart contract. In the very first line, we need to specify the license identifier. In this case, that will be MIT, SPDX license identifier, that will be MIT. Once we have specified our license, thereafter, we need to specify the Solidity version, which version of the Solidity language are we going to use. So in this case, I'm just going to go and make it to 0.8.20 and upper character symbolizes that we are going to use 0.8.20 and its upper versions. Now we will initiate our contract by using the contract keyword and specifying our contract name that will be, let's say, identity, registries, and thereafter we will open the curly braces. And now, first of all, in contracts, we specify our data types, structures we are going to use. So in here, I'll make a struct of identity. So basically, struct is a data type known as structure, where we can define various data types and use them in other variables. Okay, so here we are gonna give it, first of all, a string, which will be named as document, and we need to specify that it's closed by colon. Thereafter, we are gonna have a UN, basically unsigned integer type, updated at, and then we will have the version, and which version are we going to use. Thereafter, we will also have the address of last update, whoever made changes last. Now we are done with our structure. Now we need to define a mapping. Mapping is basically a pairwise structure which defines connectivity like from address to identity, from integer to address, like that. So we will just use a pair of address with our identity structure and make it a public variable of identities. Now we have got our mapping. Now we need to specify the event. Events are basically pop-ups which are logged to our ledger of blockchain through which we can track the state of it. Like the function is called and this event will be emitted and it will be logged onto the blockchain so that we can easily update it in the front end. Okay, so we will make identity updated event in which we will have few parameters that we'll also take in our function. First one will be address, which indexed storage type, which will be owner of the identity, string of document, and then we will have a version. Okay, that's how we do it. Now we are gonna uh, make our write functions, which basically writes on the state of the blockchain through which we need to sign the transaction. The first function which we will make is say set identity. This function will basically take a parameter of a type of storage called data, which is our document. This will be our IPFS hash of document string, right? This function will be external, but it can be called to external sources. Okay, and now we need to specify this function. First of all, we will use our structure and make a new variable known as red and specify it to the identities mapping, provide address in here to map it with address, right? Thereafter, we need to update this whole variable with all the required specifications. The document will be equal to suppose string. Thereafter, dot dated at will be equals to basically block dot time. So time block will be minted. Okay, then we will have unchecked variable dot version equals to rec dot version plus one. This will basically generate the version for our identity when was it updated. And lastly, we'll rec the last of data equals to message dot sender. Thereafter, normally we will just emit the identity that we just made. Okay. This function will call the event that we had made. Now we have a set identity function. Now we have the set identity function. And here in string we will provide to the document string, which we are taking as an input parameter. Okay. Now yeah, we are completed with our set identity function. We can write another function, which will be clear identity. If someone wants to, clear its identity from our data, so that we won't be upkeeping the records for him. Okay. For this, what we are going to do is, in the above same manner, we are going to create a new data structure like rec and provide the same parameters, but this time in the document string, we are going to update it to the empty strings, which will basically clear out the hash of the document. And yeah, rest will be the same. And we need to, emit the event that is identity updated to, empty strings with document hash and track the version. Now, these will be our writable functions. Now, we need to specify the read functions. Read functions are those which are basically calling the data from the blockchain. They are not using any guess. They are just fetching the data from the blockchain. So in here, first function which we need is basically get identity. This is going to be too basic. General and all some complex functions here. Identity will basically take address of the owner, and this function will be external function. When we are fetching the data from the blockchain, we can specify it as a view type, which will be returning string of memory storage type document that will be hash. And here we can just simply return our identities mapping along with the owner address. Owner with the document that. And yeah, this function will simply return the identity document hash of owner. Now this is the read function which we need. But if we also want to fetch the metadata from the identity, we can specify one more function, which will be get identity metadata. This function will also take this owner as parameter, and this time it will also be a style view function, which will now return, return the string memory document. After the document, we will return basically unit type updated at, and thereafter we will return the version followed by the address of last updated. Okay, so that's gonna fulfill our functions done. And now what we are gonna do is we are gonna go and create a new mapping service, which will basically fetch the info from our owner, and then we are gonna just return all of the data types from that mapping, which will be the document, updated at, dot version, and last updated. So yeah, finally our smart contract is completed. We will just put an colon here and correct its spelling. Yeah, we are good to go. And once I hit Control S and compile the smart contract, you can see our license identifier is giving us a warning. So what's that is, cause this just a typo, I just need to put this in to this manner. Okay, so now when we compile our smart contract, as you can see, we have no warnings and we are good to deploy our smart contract. So what we'll do is head over to the deploy tab and connect our MetaMask wallets. That is the injected provider MetaMask. And yeah, as you can see, it just automatically fetched my wallet details, wallet address, Rootstock Testnet. And now what we're going to do is we're going to just deploy. As you can see, my MetaMask wallet has popped up. I can just hit confirm and it takes around 30 seconds to complete the transaction. As you can see, our faucet tokens has already dropped to 2. We just wait till the contract deploys. Yeah, as you can see, our contract is successfully deployed. We can also check it on the Explorer of RSK Testnet. Our contract is deployed, and this is our contract address. Now, though our contract is successfully deployed, we can check it out in the deployed contract session. We can just call our functions from here too. But what we are going to do is we are going to go ahead and deploy our. We are just going to go ahead and make our front end and integrate it with backend and IPFS. So let's just go ahead and in order to deploy our front end, we need to open up the command prompt and I'll just open up the reference directory for the code. First of all, we are going to use the DID template. Okay, guys, so this is the directory of our project. We have 2 branches here. One is the template and another one is final. The template is the basic minimal front end, which you can implement all the functionalities of Finality. We will, for this tutorial, just clone the final branch. I'll just open up the command prompt, and in here, we will cd into the rootstock folder, make a directory as a did rootstock, and here we will just go to did rootstock, and now we will git clone the repository, and here we will specify branch by -p to the final. Once it's cloned, I'll just head over to the directory, and in the front end part, we will just put npm install so that all of the dependencies shall be installed. We'll just wait until the dependencies gets installed. Yep, so our packages are successfully installed. Now we can open our directory with code. Let me just open it. Okay, so as you can see, this is our project. This is our folder structure. We have frontend and smart contract. Smart contract is the one which we deployed via Remix. And here in our frontend, we have all of the packages in package.json. This is a standard Next.js directory. We have app, folder components, config, contract hooks, etc. We'll go into each of it. But firstly, let's just go ahead and check out our dApp by running npm run dev. And yeah, it's opened up on our localhost port :3000. We'll just wait till it opens. As you can see, we have some arrows of libraries. We'll just install it and get rid of them. Rootstock. So guys, as you can see, our dependencies are successfully installed. Now we have got our UI. It's quite clean, simple, and functional. We can just connect wallet from here. Just put on my password, hit connect, and you can see my wallet address. We have 2 options. One says mint your DID and my DID. If we don't have the DID, it will say no identity found. Okay. Now, let's go ahead and check out the code first, then come back here and mint our DID. So in the code part, first of all, in our components, we have the providers. The provider is basically a wallet provider, which basically establish a connection to our MetaMask from our UI. Okay, we have specified the rootstock chain configuration here. It's ID, name currency, decimal symbol, okay, RPC URL, and block explorer URL. Thereafter, we have config. We are just creating this config in a correct format. and injecting the shim disconnect to be true. Thereafter, we are implementing the server-side rendering to be true and providing the RPC as its transport. Thereafter, we are establishing a query client with options of queries and configuring it correctly. And lastly, we are exporting our wallet provider with wagmi provider and giving the config parameter into it, and query client provider that is just given by create query, and the create config http wagmi provider from wagmi. Yeah, and yeah, we are just putting children inside of these tags. Okay, once our wallet provider is successfully implemented, we can head over to app directory, and in here we will go to the layout page and we'll just import the wallet provider here. And here, once imported, we just need to wrap our wallet provider as a parent component under the as a parent component of the children tag. Okay, once it's done, we will be able to connect wallet functionality from our front end, and thereafter we need to have some connection to call functions from our smart contract. Okay, so for that purpose, we are going to define hooks. Hooks are basically those defined functions which basically put a call onto the blockchain function. That's okay. In here, we are importing use read content, which will basically call read functions, the callable functions from the blockchain, which will just fetch the state of the data from the blockchain. Thereafter, we are using use write contract, which will call the writable functions, the signature functions on top of blockchain, and we are just using wait for transaction receipt to get the receipt of the function. We are importing these from wagmi. Thereafter, we have defined contact address in our config/contact. I'll just show it to you. Yeah, here we have our contact address, which we are importing from our .env file. You can just define a .env here, which we will do in a bit. Okay, so we'll just head back to our hook. In here, we are just using our read hooks firstly. First of all, we have a use get identity function, which takes basically owner address as a parameter. And then we are using these address ABI and function name with arguments to call the get identity function from the blockchain. Thereafter, we have the use get identity metadata function, which basically returns all of the info of metadata from the smart contract. Here also, we are just calling the function by providing address ABI and arguments. Okay, so those were our read function. Now we have write hooks, which basically call our write functions. So first of all, we have our useSetIdentity function, basically use the useWrite contract hook and calls the function setIdentity here in the write contract and address the contract ABI and arguments as its parameters, which basically returns a set of data. Thereafter, we have a last function, which is useClearIdentity. It will be used if user wants to clear its identity. Here also, we are just using the useWrite contract hook and then calling the write contract as defined here with the correct contact address, ABI, and clear identity. Now, in order to use this hook, we need to define the contact address and contact ABI in a correct manner. For contact ABI, you guys can head over to remix.ethereum.org, in which we defined our contract earlier. Let's go ahead and in our identity registrar.so, I'll hit compile, and in the compiler tab, you can just copy ABI to clipboard. And here in our code, in our contact directory, you can define our ABI folder and put ABI as tid.json file and paste it up here. That's pretty straightforward. Once it's done, we need to get the contact address, which we can either get from Remix, as it's not available in the history at the time. I'll just head over to my MetaMask wallet and get the contact address from here, from the transaction hash. As you can see, this is the contact address. Okay, you just copy this contact address and zip it in env file to create a .env, and in it we will provide next underscore public underscore contract underscore address put equals to contact address. Yeah, once it's done, now we should be able to call our hooks. But in order to make the functionality settled, we need a perfect connection with IPFS in order to upload the file, upload picture, upload the whole metadata to the app. Okay, so in order to do so, we will head over to our code, and here in the utils directory, you can see an IPFS.ts file, which basically establishes the connection to IPFS using Pinata. I can just show you. You can head over to Pinata. You can just head over to Pinata IPFS, which is basically crypto's file storage using IPFS, and we can just log in here from Google. I'll just log in with my ID. Yeah, once that's done, you can check out all the files which are uploaded. I had uploaded a bunch of files earlier, so you can see them. Here in the developer options, we can head over to API key and just grab our API key from here. We'll just define a new key and get the JWT secret and put it into the .env file. I'll just do it by myself, and you can just generate yours and chip it in. Once we have got our Pinata JWT, we will define it as an env variable in here. Save the file, And let's just go ahead to IPFS.ts and explore all of its functionality. First of all, we are using the Pinata API URL. That's api.pinata.cloud/bin/bin file to IPFS, and using the same Pinata JSON URL. After that, we are defining some interface for correct types. We have upload image response and upload metadata response. Thereafter, we are putting our main functionality, that is upload image to IPFS, which basically takes the kind of promise of string and then creates a new form data and append it with the file and put the Pinata metadata with json.stringify and gets the file name and puts the metadata in it. Thereafter, it also appends it with the Pinata options, and in response, it basically provides the post method to the API of Pinata URL and use our JWT and perform operation, and in return it basically gives us the IPFS hash that it generates of the image. Okay, thereafter we are uploading the metadata to IPFS. Metadata is basically a file which will have all the metadata is basically a file which will have all of our data such as name, email, image, description, hash, etc. Okay, so for it we are just entering our data in it and putting created at so that it knows when it was created. And thereafter, we are providing the post API with the authorization, and in body.json, in the body, we are providing json.stringify with Pinata content, Pinata metadata, and Pinata options. Thereafter, we are just fetching the response of metadata hash. And after that, we have the function to upload identity to IPFS, which basically upload image and metadata to IPFS and returns the metadata hash. Here we are taking a name, email, image file, and it's just defined the image hash as a string or undefined. If image file exists, it will just go ahead and fetch the image hash, and thereafter it will also get the metadata hash and return the metadata hash. Now lastly, we have the fetch metadata from IPFS function, which is used in order to fetch the metadata from IPFS using the original IPFS gateway if you want to use that. Okay, and here we are also defining the hash and providing the IPFS gateways, and here we are running the for loop and providing gateways that it should get the content, and we are just defining a data variable and awaiting the response.json in it, which basically returns the data by fetching it from the IPFS. Okay, so this was all of the functionality which we are using from Pinata and IPFS to perform several operations like uploading image to IPFS, then uploading metadata to IPFS, fetching both of them, and displaying it on our front end in our UI part. So now this is our main functionality stuff. In order to now integrate these functions, we need to head over to our frontend, that is page.tsx file. So in here, the Web3 stuff is, first of all, we are defining a connect wallet button right here, which basically calls the hook of user account, and if the account is connected, it basically shows the address, and if not, it just pops up the MetaMask. Okay, same wise, we have the disconnect button in order to disconnect the wallet. Now we have two pages in here, which is min DID form and my DID view. If the user has DID already, he will just go around the my DID view. If not, they'll just go to min DID form. Okay, we can head over to min DID form. In here, we are just defining a form and fetching all the data from it. Once it's done, we are using a use effect function in order to set success, set submitting, set form data, etc. And thereafter, we have defined some function in order to handle input change, in order to handle file change, and handle submit, which is basically a form functions in order to fetch data and inputs. Okay. Now the Web3 part is we are here calling upload identity to IPFS function, which basically uploads form data.name, .email, and .profile picture to our IPFS and returns the hash, and thereafter we are just setting that identity hash to our metadata. Once it's done, it will just alert that our user's profile is successfully minted, and they can see it in our mydidview.tsx. Okay, so in mydidview.tsx, we are just fetching these states from our IPFS fetch function, which we defined in IPFS.ts file. Okay, in here we have a bunch of use state snippets. Okay, we have copy, set copy, we have reveal, set reveal, metadata, loading, etc. And thereafter, we are just checking if the account is connected or not. If it is, we are just continuing. And here we are calling our use get identity and use get identity metadata function along with the address of the owner. If it is connected, we are just passing the address and getting all the returns of data in our console so that everything works smoothly. Thereafter, we are basically loading all those data into our front-end part by another use effect hook. We have the fetch metadata from IPFS function, which takes stock value, and thereafter set metadata to the fetched metadata and set the loading to false, which basically returns us with all of the data which is fetched in the front end. But if there's no metadata, it will try to fetch from the document. It will just call again the fetch metadata from IPFS function from the doc value and set metadata to that. If not, it will just show failed to load metadata with a great UI in order to sustain it. After we have our DID address in which we are putting our wallet address as it is and putting a DID colon RSK in front of it. Right. Thereafter, we have the copy function and normal TypeScript and JavaScript functionalities. And thereafter, we have our loading state UI, which basically shows up when either the wallet state is at loading, which basically shows up when the wallet state or the state of UI is at loading. Now we have all the front end part, which we are just fetching the data and showing it to our front end, like address to address and document to the type of the document. And we have several buttons to go to the Mint tab. And yeah, that's about it. Now, though we have gone through each line of code and got to know what each line is performing, we can just simply head over to our Rootstock identity UI. And in here, let's try to mint an identity. Let's say Rhythm Nagrani. In here, I'll just put in my ID. Okay, I just made my env under the smart contract folder. We'll just put it in our front-end directory, and we should be good to go. Now our MetaMask has popped up, and it's Rootstock Testnet, so I'll just confirm it. Once it's confirmed, our transaction will take place, and once it's done, we can see your DID has been successfully minted on the chain, and a success message in here too. Okay, now when we head over to my DID, now as you can see, it's got my profile picture, full name, email, status, version, blockchain created at, and it's a verified identity, and it has also got me this IPFS hash. Now we can also see our wallet address from here. And yeah, that's about it. We can mint our DID onto the chain and upload it to IPFS, which is basically a decentralized identity. And that's it, guys. Look at what you have built. This is a complete decentralized identity system on top of Rootstock with IPFS, that is Pinata integration. You now have deployed your smart contract. This is basically a production-ready identity registrar.sol string storing the IPFS string hashes on Rootstock Testnet with Bitcoin security. Thereafter, we have implemented IPFS integration with the Pinata. Okay, we can upload our images to IPFS gateway and upload the metadata to it and fetch it. We also have the React Frontend, which is built with modern UI with TypeScript, wagmi for wallet connections and real-time blockchain interactions. This is our complete architecture. We have client, MetaMask, blockchain, IPFS, all layers working together very, very smoothly. Okay, you got to know about Remix ID, Veeam interactions, event listening, transactions handling, etc. This is basically real infrastructure. You can use it in the production level. So now I'm leaving with you a little challenge which you can implement in our decentralized identity. You can basically include a verifiable credential system. You can add a credential issuance to the smart contract, storing credential metadata on IPFS, adding credential verification systems, building a UI for issuing credentials like KYC badges. Okay, and lastly, display credentials like badges tags on top of user's profile. This you can use as a starter code, which you can get easily from our GitHub repository. You can build it, deploy to Rootstock Testnet, and practice more and more. You can even take this further and include NFT profile pictures, social recovery, and maybe a reputation system. Now, that was it for the video, guys. Here are some of my final thoughts, which can lead you to more description of this identity dApp. A decentralized identity is basically the foundation of Web3 infrastructure. Every dApp nowadays needed. You know how to build it. Rootstock gives you Bitcoin security for identity. That's pretty powerful. IPFS basically gives you decentralized storage, and that's essential in today's world. Together, they create basically an unstoppable identity infrastructure. So don't just watch tutorials. You need to practice a lot, build, deploy, ship. The ecosystem of Rootstock is very helpful. It needs builders like you. Thank you for coding with me today, guys. And keep building, keep learning, and I'll see you in the next one where we are building. Happy coding.